In today's lesson, we will be applying the linear function, in which we will be looking at real-world scenarios in which the linear function applies. Through story problems, we will have to create our own equations, linear equations, and then graph those equations. When you are reading the story problems, you want to look for certain things. Our goal is to write an equation in slope-intercept form, mx plus b. So, through a story problem, you have to find the slope. And I just want you to always think rate of change. So, what is changing over time? And then you also need to find the y-intercept. And remember, the y-intercept would be the value when x equals 0. Or, trying to find the dependent value when the independent value is 0, which is x and y. And certain scenarios, it might be like initial fee or the starting amount are keywords to look for in story problems. And then the last thing that you have to look for is after reading the story problem to know what kind of graph to draw. Maybe for this first graph, we only want coordinate 1, where x and y are positive. So your graph would look like this. Or the second graph, this is where x values are only positive, but y values could be positive and negative. And then the last scenario in which we want both x and y to have positive and negative values. So throughout the story problem, you have to decide which graph makes the most sense. Okay, here's our first example. A car dealership has 40 cars in stock. So this is what they already have. And then the auto manufacturer will deliver new cars to the dealership by a car carrier. Each carrier holds 6 cars. So write a linear function that relates the number of carriers used to the total number of cars at the dealership. Graph the function that models the situation. So think about the rate of change and the initial amount. In this case, they started with 40 cars. So with 0 carriers, you will still have the 40 cars. And then each carrier that comes, it will increase the total stock by 6 cars. So it's going to increase 6 per carrier. So my equation, y equals mx plus b, is going to be y equals 6x plus 40, where x is the number of carriers. So now that we have our equation, we need to decide what kind of graph that we want. We're going to start at 40, and it doesn't make sense to have negative carriers or a negative total number of cars. So I want to make a graph that is only going to look at positive x and y values. So I've labeled my graph where the x variable represents the carriers and the y variable represents the total cars. So to graph this equation, I would say sometimes the easiest thing to do is just to make an XY table. And let's consider how many cars are at the dealership if 0 carriers come by, or if 5, or if 10 come by. Because if we have 3 points, we can just plot 3 points and then connect them in a straight line. If 0, so you're plugging in for x and then solving for y. If there are 0 carriers, there's still the initial 40 cars. If there are 5 carriers, 5 times 6 is 30, and 30 plus 40, there'll be 70 total cars. And if 10 carriers come, 6 times 10 is 60, plus 40 is 100. So let's label our graph. On the bottom, let's say we count by 1. So each unit is going to just represent 1. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then on the y-axis, let's count by tens because we're going all the way up to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So now all we have to do is plot our points. At 0, we have 40, so that's the y-intercept. And then at 5, we have 70. And then at 10, we have 100. So our dots should fall in a perfectly straight line. And if you connect, here we have the graph of the linear function that represents this equation, y equals 6x plus 40. All right, next example. Suppose an elevator is 400 feet above the ground. It descends at a steady rate. After 15 seconds, it is 250 feet above the ground. Write a linear function for the height of the elevator as a function of time and graph the function. So in this situation, our two variables are time and feet. So you can think about our coordinate points. We'll have time as our x value and feet as our y value. So let's think about two different points that we can write based on this scenario. If it starts at 400 feet above the ground, that means at 0 seconds, it is at 400 feet. And then at 15 seconds, it is 250 feet above the ground. So from these 2 points, can we find the slope and the y-intercept? Well, this point, 0, 40, basically is the y-intercept because the y-intercept is always the y value when x is 0. So we know right away that our y-intercept is 400. And now we just have to find the slope between 2 points. And remember, that's the change in our y values divided by the change in our x values. So we want to look at the difference between 250 and 400. 250 minus 400 divided by the change in the x values, 15 minus 0. Which equals negative 150 divided by 15. And that equals negative 10. So I have the y-intercept of 400 and the slope of negative 10. So my equation is y equals negative 10x plus 400. So now to determine our graph, we want to think about, will we have any negative values for our variables, for time and for feet? Well, for time, it does not make any sense to have negative values, and then feet, it also does not make any sense to have negative feet unless the elevator goes below the ground into the basement. But to keep things simple, let's just assume there is no basement in this building. So we're going to have all positive values again. So to graph this equation, let's make another XY table. We actually already have 2 of the points. We know that at 0 time, we're at 400 feet, and that at 15 seconds, we're at 250 feet. Now, let's consider how much time would have gone by for us to be at 0 feet. In other words, if you plug in 0 for y, what value of x would give you 0. Well, 400 plus negative 400 would give you 0. And to get negative 400, you'd have to multiply by 40. So at 40 seconds, you are at 0 feet. So for my x-axis, I counted by 5s and labeled every other unit up to 50. And then for feet, I need to go from 0 all the way up to 400 feet. So on the y-axis, I counted by 50s, labeling every other unit. So now I can just plot my 3 points. At 0, I'm at 400 feet. At 15 seconds, I'm at 250 feet. And then at 40 seconds, I'm at 0 feet. And we can connect those 3 dots for our linear graph of this equation. Alright, here's our last example. It costs a farmer $100 to bring 130 pounds of apples to the market. And apples sell for $3 per pound. The difference between the income from the sales and the cost is the farmer's profit. Model the situation with a linear function and graph. So the sentence I underlined is kind of what we're going to use to make our equation. The difference, so you're looking at subtraction, between the income, so how does he get income? He gets income by selling apples at $3 per pound. And then the cost, how much did it cost the farmer? Well, it says here it cost the farmer $100. So, y equals, so his income is $3 per pound, but he had to spend $100 of his own money. So before he gets to the market, he's actually in the hole $100. He's negative $100. And then he's going to sell a lot of apples to then make a profit. So we want to think about what kind of graph will we want to draw. And in this situation, if he goes to the market and does not sell any apples, how much money will he have? He'll have negative $100. So if there are 0 pounds of apples sold, he'll be at negative $100. But you don't want to consider negative apples. So when you make your graph, you want to think about the y value, the money. We want positive and negative numbers. But for the apples, we only want to consider positive numbers. So my graph is going to look like this. So we can consider positive and negative money, but the x-axis only represents positive pounds of apples. So once again, I'm going to make an XY table to get a few points so I can draw my line. Starting with 0, we know that if you sell 0 pounds of apples, his profit will be negative $100. If you plug in 50 for x, 3 times 50 is 150, and then minus $100 will be $50. So 50 pounds will give him a profit of $50. And then 70 pounds, 3 times 70 is 210, minus 100 is 110. So let's graph those 3 points. 0 is at negative 100. At 50 pounds is at $50. So 20, 40, 50. And then at 70 pounds is $100. So connect those 3 dots for our linear graph. So there's our lesson on applying the linear function to real-world scenarios. Always trying to figure out in the story problem what is your slope and what is your y-intercept, and then using that information to decide how to make your graph and how to make your equation. Good luck with the lesson.